mitochondria are the organelles in your cells that are always thought as the powerhouses of the cell. They make ATP, but the mitochondria do many other things. They make metabolic water, which is deuterium depleted. The water in your cells can absorb red light and infrared light and make a battery in addition to just making ATP energy.
Because that's what makes all energy in our body. And you don't have to be a rocket scientist or a doctor to realize that a body that has no energy is called a cadaver. A body that has a lot of energy is called healthy. So guess what we should be focusing in on?
Your environment gives cues to the mitochondria what they're supposed to be doing during that time of day. Different light coming into the system tells the mitochondria when to make energy. If that light isn't present, the mitochondria will see higher levels of melatonin. They know it's time to do the repair and replacement programs at nighttime. So the mitochondria are always looking at your environment, what they should be doing. The heart and the brain are the two locations with the most mitochondria. The heart approximately is 1/3 by weight mitochondria. So when the mitochondria get broken, heart disease develops. And the mitochondria are most sensitive to their light cues. So your light-dark cycles, the timing nutrients come in. And so when your mitochondria make energy for you, the heart function is optimal.
And what the cell needs to run, the mitochondria, not of the retina of the brain, every cell in the body, you have to have photonic energy, light, you have to have electrons, protons, and oxygen. And if you don't have those things in proper supply, electron chain transport slows, it increases free radicals in every cell in the body, and the free radical signaling changes, and that's what causes disease.
So a cardiomyopathy or a weakened heart muscle is due to mitochondria that don't make enough energy for that tissue to contract or relax. It actually costs more energy for the heart to relax than it does to contract. And in traditional training, we would see this diastolic heart failure frequently. And the only thing we could ever really recommend people was, well, let's control their blood pressure because maybe that's going to be the best thing for them. But never got to the root cause of what was causing the diastolic dysfunction.
In fact, that's actually how diseases manifest. As energy production in the mitochondria drops, diseases manifest. Is that Jack Krus's observation? No, it's Doug Wallace's observation. He's probably the world researcher that's done more for mitochondrial biology than anybody else. He's at the Children's Hospital of Philadelphia. He's been doing this for over 40 years. He's the guy that figured out we only get our engines from our mom. So that means mitochondrial DNA is only inherited from one parent. That's pretty cool stuff. That's not true with DNA or RNA.
And Doug Wallace has shown we've studied the wrong genome. The mitochondrial genome is very important. And that's why understanding someone's maternal history, and I ask those questions all the time, and they're asking, well, I've got heart disease in my family. Well, which side? Why does it matter? It matters because your mitochondrial genome is inherited from your mother. And so if you know the maternal history, if somebody's got cancer in their mom in her 40s, we got a lot of work to do as it relates to their circadian system, their light, and in their mitochondrial health.
98% of the NIH budget goes to studying the DNA and RNA genome. And it turns out, where should the money be going? To the other genome that's in our cells, called the mitochondrial genome, the genome that makes all the energy. And here's the shocking thing. The DNA and RNA genome has about 22 to 25,000 genes in them currently today for a human. And guess what we've known from the get-go? We have 37 genes in the mitochondria. Don't you think it'd be a little bit easier to tackle 37 genes than it would be to do 25,000, considering that 13 of the 37 genes are solely tied to making energy in a mitochondria?
And only until I discovered circadian biology, quantum medicine, and I understood how mitochondria actually work, it's, fixing the mitochondria is going to fix the diastolic dysfunction.
Because if you focus on the mitochondrial genome, even if your doctor ignores it, you will get better in spite of your doctor.